Thank you.
Hello, doctor. Can you hear me? I think your microphone is muted.
Yes, chào Professor Ghost.
You have idea how many people are joining online?
Hello.
Okay,
Hello,
Doctor.
everyone.
Yeah, Atola, how are you?
I am fine. And how are you?
Good, good, good. How is your base? You are in Pakistan now? You can hear me, right? So I think Professor Sun is a bit busy, but I'm going to help share the presentation and session, okay?
Can I start the session?
Let's wait until just about 3 minutes and
Okay,
see.
okay.
Yes, so about 3 minutes, then you can start the session. You can put the post the topic of the presentation, please. Can you put the topic? Your slide is showing the thank you slide. Okay, you can put the first page. Okay. All right, so I would like to welcome everyone for this presentation. So presentation is going to be made by Dr. Atwala. So Doctor, he's a faculty member at the University of Central and completed his PhD in 2024. So yeah, he is specializing in fuzzy systems and fuzzy aggregation operators and also decision support systems. So as we can see from the presentation title, it's an AI-driven healthcare decision support system using generalized fractional Orthopair fuzzy rough information. Okay. So we're going to start because our time is, we have this presentation from 9 a.m. to about 11 a.m. So doctor will make a presentation. He will introduce himself and then also go ahead into making the presentation. And after the presentation, we have question and answer sessions where some of the participants in this will ask you some questions regarding the topic, and then after that, we will finalize the session for today. Is that okay?
Okay, sir.
All right. So, ladies and gentlemen, I hereby introduce Dr. Atfola Atta for his presentation.
Hello, everyone. Let me to introduce myself. I'm Dr. Ataullah. I did a PhD from Abdul Khan University, Mardan, which is among the top university of Pakistan. I have a strong background in research and teaching. I published several research articles in well-reported journal. My impact factor is about 100. I served as a lecturer at University of Lahore for 2 years and served as a lecturer at Bacha University for 6 years, and currently I am serving as a lecturer at University of Chhatral. Secondly, I received STEM faculty training at renowned UK university such as King College London, University of Birmingham, and University of York University. As a certified trainer, I am conducting a faculty training session in Pakistan, contributing to the academic excellence in Pakistan higher education sector. Now I am going to start my presentation. My presentation topic is AI-driven healthcare decision support using generalized fractional orthopair rough information. These are the presentation layout. I will discuss about background and motivation, literature review, proposed problem. And here I discuss only these two problems: Permitian hesitant fuzzy rough averaging irrigation and the replication and green supplier selection, and Q-rang orthopair probabilistic hesitant fuzzy rough averaging aggregation information and the replication and selection of medical oxygen supply per hospital. And then I will discuss about the upcoming projects and upcoming research. First of all, I'm discussing about the background. Let me discuss about the fuzzy seat. Fuzzy seat introduced by Zadeh, and that is the concept which is the structure of the farm. Here, this one is a membership function which belong to the value of membership function belong to 0 and 1, and this is called membership function. And then Tora et al. Develop the notion of hesitant fuzzy set. during making decision, there is a hesitation for the decision maker that how to select something. For removing the hesitation, Torah developed the notion of hesitant fuzzy seat. And hesitant fuzzy seat, this is a membership function, but this function of the element of the set and represent the set of values a contain in 0 and 1. The membership function belong to this is these are the set values belong to 0 and 1. After that, I discuss about the probabilistic hesitant fuzzy set. A probabilistic hesitant fuzzy set is just the extension of hesitant fuzzy set, where they introduce the probability of a membership function. This shows the probability of element, and you know the definition of probability, that the sum of probability must be equal to 1. Then Atnasov introduced the intuitionistic hesitant fuzzy set. An intuitionistic hesitant fuzzy set, they introduced the non-membership function as well. This is a membership function, and this is a non-membership function with the same condition. The membership function is also
Think doctor is having a internet problem glitch, so he will log in again, please.
Are you hearing me?
Yes, we can hear you. I think you have an internet glitch, right?
Due to net issue, the connection was there a problem in internet. Sorry about that.
Okay, you
I'm
can go ahead.
then I am discussing about intuitionistic fuzzy set. Atnasov introduced the idea of intuitionistic fuzzy set, which mean a structure of the form. Here, this
Can you share the screen again? Can you share your screen again, please? Thank you. Yes, it's trying to share the screen, so you will share the screen shortly, please.
I'm sharing it, but there is a net issue. I'm sorry for that.
It's okay. Technical glitches normally. Oh, can I share for you? Can I share your screen from my side?
Please share it if you can. Here is a net issue. Okay, I'm sharing. I am sharing now.
All right, okay. Okay, your screen is up now. You can continue.
Okay. Sorry for the disconnection. Let me start.
Please start.
Discussing about the intuitionistic fuzzy set. And Atnesov introduced the idea of intuitionistic fuzzy set, in which they included the non-membership function as well, with the same property that the membership function also belong to 0 and 1, and the non-membership function also belong to 0 and 1, with the condition that the sum of the membership function and non-membership function must be greater than 0 and less than 1. Then Jager introduced the concept of a Pythagorean fuzzy set. Uh, Here they extended the idea of intuitionistic fuzzy set by just introducing that the square sum of membership and non-membership must be less than or equal to 1. And then Jager further introduced the idea of Fermatine fuzzy set, in which they discussed that the cube sum of membership and non-membership function must be less than or equal to 1. And then they further introduced the idea of Keurang-Arthur fuzzy set, in which they discussed that the fourth sum, the fifth sum, the fifth sum, this they increase the value of Q, for which they discuss about the Keurang-Arthur fuzzy set, which is the extension of Fermatian fuzzy set. This is the flow diagram of intuitionistic fuzzy set, Hermitian fuzzy set, Pythagorean fuzzy set. This the green line show the graph of intuitionistic fuzzy set, and this is the probabilistic Hermitian fuzzy set, and this is Pythagorean fuzzy set, and this is Hermitian fuzzy set, and we can further extend this notation as well. Now I'm just discussing about the rough set and their generalization. Falak introduced the idea of rough set in 1982. The concept of rough set has been extended by several research in diverse directions and discussed their replication and decision making. Many researchers have discussed about the Falak rough set, and they implemented the replication and in diverse area of decision making. And just Dose and Pratt were the first to introduce the fuzzy rough set. They Falak introduced the rough set, and in rough set there was no restriction on the domain, but Doofs and Pratt extended the idea by introducing the concept of fuzzy set and rough set. And then the fuzzy rough set was used by several authors and several researchers uh, to solve many real world challenging problem. Cornelius developed the idea of intuitionistic fuzzy rough set. Just we discuss about this one intuitionistic fuzzy set. This like uh, this one intuitionistic fuzzy set. They introduce the idea of intuitionistic fuzzy set and rough set. They combine both these ideas. Those introduce the idea of fuzzy set and rough set, and this and uh, then the then the idea of intuitionistic fuzzy set was introduced by Cornelis, and then the idea of intuitionistic fuzzy set was discussed by several researchers in real-life challenging decision-making problem. Chinaram et al. Established a list of aggregation operator based on intuitionistic fuzzy set and discussed the replication and decision-making. Zhou and Wu established a novel decision-making technique under intuitionistic fuzzy set and they addressed the replication and decision-making. Like that, Zhang et al. Presented decision-making methodology and under intuitionistic fuzzy set and explored the replication in real-world problem. This is the definition of intuitionistic fuzzy set. Here, this one is the lower approximation operator, and this one is the upper approximation operator, with the condition that the lower approximation operator will not be equal to upper approximation operator. If this is a fuzzy subset, then the lower approximation operator will be also a fuzzy set, and the upper approximation operator will also be fuzzy set. If this one is intuitionistic fuzzy set, then the lower approximation operator will be also intuitionistic fuzzy set, and the upper approximation operator will also be the intuitionistic fuzzy set, just with the same condition that the sum of membership and non-membership must be greater than or equal to 0 and less than or equal to 1. This condition is for the lower approximation operator, and this condition is for the upper approximation operator. Both the lower approximation operator and upper approximation operator are intuitionistic fuzzy set. Uh, now, I'm just coming to the proposed problem, just the Permitian hesitant fuzzy rough aggregation operator and the replication and multi-criteria group decision making and the novel decision model with Einstein aggregation operator. Here I publish several research articles and these ideas by introducing innovative aggregation operator par Permitian hesitant fuzzy rough set, par Kurang Orthopair hesitant fuzzy rough set, probabilistic hesitant fuzzy rough set. And just by introducing, just by extended this definition of intuitionistic fuzzy rough set. This paper I published in scientific report Permitian hesitant fuzzy rough aggregation operator in the replication in multi-criteria group decision making. Here, just like I discussed in the intuitionistic fuzzy rough set, here the lower approximation, this one is the lower approximation operator and this one is the upper approximation operator with the same condition. This one is the this one also is a lower is a Permitian hesitant fuzzy rough set, and this one is also Permitian hesitant fuzzy set with the same condition that the cube sum, the minimum plus maximum of cube sum is less than or equal to 1 with the lower approximation operator and with the same condition for the upper approximation operator. Just like you can see that the minimum of membership function, this one is the membership function, the minimum cube of membership function, and the maximum cube of membership function will be also the membership function. This one is the maximum cube of membership function, and the minimum cube of membership function will be also the maximum cube of membership function. of membership function is less than or equal to 1. With the same, this is for the lower approximation operator, and this is for the upper approximation operator. And then we discuss about the scoring function. The scoring function, we can find the score by using this formula. If the score functions are equal, then we use the accuracy function. The accuracy function of this one can be found by by this formula. And then here for this one, I introduce the idea of weighted aggregation operator, weighted aggregation operator based on Permissian hesitant fuzzy offset. This through this formula, we can compute the membership function per lower approximation operator, and for this formula, we can compute the non-membership function. This is for lower approximation operator, and this one is for the upper approximation operator. This formula, this is through this formula we can calculate the membership function of upper approximation operator, and through this formula we can calculate the non-membership function of the upper approximation operator. After that, also discuss about the Permissian hesitant fuzzy rough other weighted average aggregation operator. Here we can first we order the information, and then apply the aggregation operators, and then I also discuss about the higher the hybrid weighted averaging aggregation operator based on Permissian hesitant fuzzy rough averaging aggregation operator. Just like this is the flowchart of algorithm, how we can how we implement this idea in taking decision problem. First we have to invite different expert, and the expert will provide the information in Fermatian fuzzy rough sets. Here I consider three experts. In the expert information we collected, all the expert information will be collected through weighted arithmetic averaging aggregation operator, and then giving weight vector to the information of every decision maker. This is they collected it. First, we collected all the information through using weighted arithmetic averaging aggregation operator, and using attribute weights, weighted arithmetic aggregation operator. These are the aggregated information, and using the score value. Just I discuss about the score value and accuracy function. If the score values are equal, then we use the accuracy function, and by using the score value we can rank the alternative, and discuss about the optimal alternative with maximum score value. If the value is maximum, then we consider that this one is the best alternative. Just like I present here only the information of one expert. Here I consider four attribute. This is A1, A2, A3, A4, and four criteria: XI1, XI2, XI3, and XI4. This is the expert information one, and then I implemented the aforementioned techniques, and discuss about the ranking order here in this flow, graph. You can see that Fermitin hesitant fuzzy rough weighted averaging, this the green, the blue bar shows the result of Promethean hesitant fuzzy rough weighted averaging, and we see that A3 is the best option because the A3 has a highest score value. And just for the brown color, you can see that Promethean hesitant fuzzy rough order weighted averaging. This brown color shows the result of Promethean hesitant fuzzy rough order weighted averaging. Here again A3 is the best option, and gray color you can see that this is the result of Promethean hesitant fuzzy rough hybrid weighted averaging, and again A3 is the best option. Now, for comparative analysis, I implemented the VCORE method, multi-criteria optimization in compromise solution approach. This was developed by Aprokovic and Zhang. Here I can discuss about the steps how we can implement the VCORE method for permitted hesitant fuzzy upset. Just like we construct evaluation matrices of all expert in the form of permitted hesitant fuzzy value. All the expert information are given in the permitted hesitant fuzzy value, and then I use the Promethean hesitant fuzzy weighted averaging aggregation operator to compute the collected expert information, and then based on the score value of information, compute the positive ideal solution and negative ideal solution, just like I presented here. This is the positive ideal solution and this is the negative ideal solution. And then we find the utility measure and regret measure. This is ASI and ROI by using this formula, and determine the maximum and minimum value of S and R respectively. This is the minimum value of this one, and this is the maximum of SI. Both the SI and RI are calculated by this formula using the in SI. This one is the distance between all alternative and positive ideal solution, and this is the distance between the positive ideal solution and negative ideal. And then integrate the feature of both the group utility measure SI and the visual regret measure RI in order to access the ranking measure QI for both alternative. Using these value utility using the value of utility measure and regret measure, and find the value of QI. This is a ranking measure. Here the value of xi between 0 and 1, and however the common way, mostly all the researcher mostly using 0.5 the value of xi. The alternative are order and descending. All the alternative are arranged in descending order for SI, RI, and QI. Here we obtain 3 ranking list that will be determine the best compromise alternative. Here this graph show the outcome obtained through the VCORE method. Here again you can see that A3 has maximum values. We obtain and all the 3 aggregation operator. This is the weighted averaging, order weighted averaging, hybrid weighted averaging, and VCORE method. We again find that A3 is the best alternative. Again, to further validate our aggregation operator, I used the Topsis approach for Promethean hesitant fuzzy upset. This approach was developed by Hong and Yon in 1981. The step, again, I'm just discussing about the step, how we can implement the Topsis approach. How we can implement the Topsis approach for the Promethean hesitant fuzzy upset. First of all, we collect all the information from the expert based on Promethean hesitant fuzzy upset, and then using the aggregation operator to compute all the collected expert information, and again compute the positive ideal solution and negative ideal solution, this is the PIS and NIS. By using again this formula, maximum the positive ideal solution will be considered having maximum score value, and the minimum the negative ideal solution will be considered having minimum score values. And this is the formula that the, we can calculate the distance between all criteria in positive ideal solution, and this is the geometric distance between each alternative and negative ideal solution. By using this formula, again this is the membership function, membership value, this is the membership value of lower approximation, and this is this is the membership of lower approximation. And again, in step 6, we can compute the relative closeness, and this is this one. Just I discuss about the ideal solution, positive ideal solution, and negative ideal solution. These both are just boundaries for positive ideal solution and negative ideal solution, and we can calculate. We can calculate the optimal solution and the boundary of positive ideal solution and negative ideal solution. And we can think about that. If the ideal solution has lowest distance, then we can consider that this one is the optimal alternative. Just you can see that choose the optimal alternative with lowest distance. We can find the distance between this one, and the alternative will be considered the optimal one, having the lowest distance. This is again the graphical representation of the result obtained through Topsy scheme for ideal green supplier selection. Here you can see that A3 is the lowest score value. So I discussed that we can find first of all positive ideal solution and negative ideal solution, and here you can see that A3 is minimum distance. So A3, we consider that A3 will be the best option. From here you can see that all the aggregation operator I implemented from all aggregation operator that I implemented has the have the same optimal value. And like in the core method that I implemented for the novel idea of Parmentian hesitant fuzzy rough set, again obtain the same alternative, and in the Tops's method. And in Tops's method we again achieve the same best alternative. This validate the authenticity of our suggested aggregation operators. Now I'm discussing about the other idea of Kyorang orthopair probabilistic hesitant. Here probabilistic fuzzy rough aggregation information in the replication and decision making. Here in this idea, in this I introduced the probability as well, and discuss about the aggregation operator for this one. Here this shows the idea of Kyorang orthopair probabilistic hesitant fuzzy rough set. Here again I am discussing about this is the lower approximation operator. This is the lower approximation operator, and this is the upper. This one is the lower approximation, and this one is the upper approximation operator with the same condition out. And this shows the probability of the lower and upper approximation and the membership function, and this shows the probability of lower and upper approximation operator for the non-membership function. This one is the lower approximation operator, and this one is the upper approximation operator. And both the lower approximation operator and upper approximation operator are Q-rang orthopair probabilistic fuzzy set. And again, with the same condition, this is the Q-rang orthopair fuzzy set, and this one is also a Q-rang orthopair fuzzy set. If we combine both in the lower approximation operator and upper approximation operator, then that become the Q-rang orthopair probabilistic hesitant fuzzy rough set. By introducing the idea probability and the Q-rang orthopair probabilistic fuzzy set and rough set. Again, this is the formula how we calculate the score function per Q-rang orthopair probabilistic hesitant fuzzy rough values. And again, if the score function are equal, then we use the accuracy function. In maximum time, we observe that if we find the score values, then the score values are all alternative are becoming same. In this cases, we use the accuracy function. If the score values are equal, then we use the accuracy function as well. Again, here I introduced the idea of aggregation operator probabilistic hesitant fuzzy rough set Q-rang orthopair probabilistic hesitant fuzzy rough values. And again, I am discussing about weighted averaging. And this one I also introduced the idea of weighted geometric function as well. Just like you see that the membership function will be calculated by this formula with the probability as well here, this with the same condition that the probability must be equal to 1. And the non-membership function will be calculated through this formula with the same condition that the probability must be equal to 1. And this all formula is for the lower approximation operator, and this is for the upper approximation operator. And again, this is for the membership function, and this is for the non-membership function. Here I'm discussing about the weighted geometric aggregation operator. In weighted geometric aggregation operator, the membership function can be calculated through this formula with the probability as well. And the non-membership function can be calculated through this formula. And this is the this formula is used for the lower approximation operator, and this formula is used for the upper approximation operator with the membership function and non-membership function. Also, the membership function included the probability parameters, and the non-membership function also included the probability as well. Next, I'm discussing about how we implement the upper mentioned aggregation operator in decision making problem. Here I discuss, I implemented this one, that how we can choose the best medical oxygen supply per hospitals. First, to start, we can set a set of decision makers. We will invite the experts, and set up alternative. We will discuss about the alternatives as well, and criteria through it. We will choose the criterias that how we can select the best oxygen supplier. Expert decision-making steps and identify the problem case study, construct decision-making matrices. Here in this in this case, we will all the expert will provide the information in Q-rang in the form of Q-rang orthopair probabilistic hesitant fuzzy rough set. And again, this one is if the information are benefit types, then though there is no need to normalize it. If this is the cost type, then we will normalize the information. By normalization, we mean that the membership, if this is the cost value, then the membership function will be changed by both the membership and non-membership function are both the membership and non-membership values are will be interchanged. And this again we can calculate the score values and rank the score value in descending and ascending order and choose the alternative having maximum score value. We will rank the alternative in descending and ascending order and choose the alternative having optimal values. Here I presented the information of the first the expert information here. Just I presented only one expert information. I invited three experts, but for simplicity, I just show only the only a single expert information. You can see that here, this is also a hesitant fuzzy set, and this show the membership values, and this is the non-membership value of lower approximation operator, and this one is the membership and non-membership par lower approximation operator, and this one shows the membership and this one here, this one is the membership and non-membership par upper approximation operator, and this one is the membership and non-membership par the lower approximation operator. And you can see that both the both the membership and non-membership function also involve the probability, and you can see that this is probability. 0.6 is the probability and 0.4 is also the probability, and you know that the sum of probability, we will consider the probability with the condition that the sum of probability must be equal to 1, just like you can see here 0.2 and here 0.5 the probability value and 0.3. So we will add that 0.3 plus 0.5 and plus 0.2 is equal to 1. So the sum of the probability must be equal to 1. Here again, I considered 4 alternative and 4 criteria. This is again the same thing. Again, by ranking the order, I implemented the same these aggregation operator just I discussed here. This one weighted geometric and weighted averaging for the information of expert, just like you see in this table. And I obtained the result of this one, Orthopair probabilistic hesitant fuzzy rough weighted averaging and Orthopair probabilistic weighted geometric aggregation operator. And then using through this table, you can see that A2 has maximum value. A2 has in both weighted averaging and weighted geometric, A2 is maximum value. So A2 is the A2 is the optimal alternative. This is the graphical representation of the aggregation operator, that is Orthopair probabilistic hesitant fuzzy rough values and Orthopair probabilistic hesitant fuzzy rough weighted geometric aggregation operator. And you can see that A2 is a maximum value. Now, for comparison purpose, I use the reliability and validity test as well. In reliability and validity test, we interchange. The just like I am showing here. We interchange the membership and non-membership function in these two, just in A1 and A2, and again this one is will be will not be interchanged. This just like these two will be not interchanged. And again these two will be, and the second one, these two will be not interchange. The membership and non-membership function are mutually interchanged, and these two will be interchanged. And then again, I implemented the same aggregation operator, that is weighted averaging and weighted geometric. This test was first introduced by Wang and and Troy. Again, you can see that the score values of all alternative, and we can observe that A2 has maximum score value. So to validate the aggregation operator, uh, I implemented the reliability and validity test for the accuracy. And again, you can see that A2 has maximum value. And you observe in the previous slide that in this one is also in these the A2 A2 is the ideal solution as well. And in the test, we achieved that A2 is also again, A2 is the maximum value, so A2 is the best alternative as well. And this is the graphical representation of the ranking order for the test. And here I also implemented the same TOPSIS methodology based on Kyorang Orthopair probabilistic hesitant fuzzy upset. And I show just the graph of this result. Here you can see that A2 has minimum value, so A2 is the best alternative. In future, in ongoing in future plan, we aim to discuss to extend the develop approach to some other fuzzy environments, such like T-spherical fuzzy wrap environment, complex fuzzy wrap environment. And I am interested in like in the fractional fuzzy. This is the novel idea introduced in the fuzzy set only, and I am just trying to extend this idea to the upper mentioned ideas. Just I or all the ideas I discussed in the previous slide. No one is working till date on these ideas. I am the one just working on these ideas, and still I'm introducing novel ideas in this in these ideas. And you can search that the Parmetian hesitant fuzzy wrap set, Pythagorean hesitant fuzzy wrap set, intuitionistic hesitant fuzzy wrap set, Kyorang orthopair hesitant fuzzy wrap set. All these are introduced by me. And no one still date working on these ideas. And now I'm just going to introduce novel idea of fractional fuzzy wrap set and the Kyorang orthopair linguistic sets to establish way and just to introduce the novel idea of similarity and distance measure per the proposed concept. Because all the similarity measure and distance measure will be introduced in the par these upper mentioned ideas to enhance the notion of par different aggregation operator. I am still working that how we can introduce different other integration operator in the upper mentioned ideas, and to implement the suggested approach in other field of decision making process such like healthcare, AI-based assisted diagnosis, variable health technology devices, pharmaceutical automotive industries, planning and control, financial decision, and planning processing. This is the one limitation of our ideas, that the Kyorang orthopair fuzzy hesitant fuzzy set provide greater accuracy, but at the cost of much time consuming. To overcome these challenges, I'm working. I develop several codes through MATLAB, and now I'm working to create, to establish codes for the aforementioned ideas, that how we implement the aggregation operators and how we can calculate the score value accuracy value, and the TOPSIS approach, core approach, and we fast approach, all approach that I discuss about the novel idea. To overcome these challenges, I'm just working on Python code, and hopefully I will establish these codes. Then it will be very easily implementable in the future. And I just show the achievement. I published several articles, and here I just show some article here as well. And then thank you. Hello.
Yeah, we can hear you. Thank you for the presentation.
Presentation, and there are participants in the about 24 participants in this presentation. So I would like to move to the portion for questions and answers, so that if anybody has a question regarding what you have presented, then they can present it to you and you can try to answer the question, okay? So I will open the question session right now. So is anybody has any question for Dr. Atalla?
Hello, could you hear me?
Yes, Bumin, we can hear you.
Yeah. Hi, doctor. Thank you for the presentation. Thank you for the presentation. I have a question, and I text in the box. So could you open the box, please?
Dr. Atalla, did you hear?
Please ask again.
Yeah, I already have. I already typed the question in the text box. So could
Okay,
you
all
open
right.
the
So
chat?
let me help him out. So he said in slide 16. In slide 16, can you go to slide 16, doctor, please? Slide number 16, 16.
2016.
Yes, 16, please. Okay. So Mr. Ming was asking that the architecture is pretty well, but if we want to have the interpretability of the decision process, is it possible or not? At least for a non-technical stakeholder like Mr. Ming, who have not much knowledge about Uzi.
Okay. The fuzzy set, I just show you that here, this is a fuzzy set with the membership function. If you choose, suppose you make a decision about taking admission or admission in any subject, then we can give value from 0 to 1. Suppose you agree to take admission in the respective subject, and you giving value 0.6. This 0.6 show your interest. And then you have also hesitate to about the future of the subject or anything else, then you will give you the non-membership function. In this one, you will use the hesitant set. And if you hesitate about the several effects partaking addition in the same field, then you will give you value. Suppose you giving value to the future of your subject, you giving value to the difficulty of the subject, and other parameter you can include in the hesitant fuzzy subsets as well. But with the condition that all the values will be and will be between 0 and 1. And in hesitant fuzzy set, this is represent the set values, and here you can in fuzzy set you can give value only and only one value, and in hesitant fuzzy set you can give value and consider many aspects of your area that you want to choose.
Okay,
Yeah, good.
Mr.
Thank you. Thank you. I
Ming,
got it. Yeah.
you have another question?
Yeah, I got it.
You got it?
Yeah, yeah. I got it. Thank you. Thank you for the answer.
Okay. Any other question, please? Mr. Tan? Any question? Mr. Tan, do you have any question to ask Dr. Abdullah?
Yeah.
I'm trying to go through the participant to see if anyone has a question for you. Okay, I have a question. Because you have already mentioned about a computational optimization strategy. Okay, so you
Yes.
mentioned the high time consumption of the QROFAS framework and that you are working on Python MATLAB codes.
Yes.
So
Yes.
beyond the basic coding, what specific optimization or approximation techniques, example, maybe dimensionality reduction on the hesitant sets or simplified boundary model for the rough sets, are you exploring to make these complex aggregation operators viable for the real-time healthcare diagnostic system? Because you mentioned in your future work. Did you hear me, sir?
Let me ask again.
Okay, so I said,
Please.
my question is regarding the computational optimization strategy. So because you
Yes.
also mentioned that there is a high time consumption of the QROFAS, okay, the framework, and that you mentioned that you're working
Yes.
on Python, the MATLAB code. So my question is, beyond basic coding, okay, what specific optimization or approximation techniques, for example, maybe dimensionality reduction on the hesitant sets, or maybe a simplified boundary model for the rough sets. So are you trying to explore to make these complex aggregators or operators viable for the real-time healthcare diagnostic systems? Because I see that you mentioned in your future work.
Yes. Currently, I am working just in MATLAB. I prepared codes for the for the aggregation operator that I mentioned. And now I'm working on the Python, and will nearly I will establish codes through Python. Now currently I'm working on this one.
Okay. All right, I got it. I also have a question regarding the justification for your Q in FHFRS, because Q is equal to 3, which is used in the Fermatian, okay?
Yes,
And
yes,
in the ROFAS model, Q is a variable, right?
yes,
So
yes.
how do you or a decision maker systematically determine the optimal value of the Q for a new or unknown decision problem? For example, you mentioned COVID-19 drug selection. So how can that be done without introducing a bias or a circular validation?
In one of my paper, I just show the this one paper I went where I show the sensitivity and analysis of Q. Just you said about the parameter Q. Here I am just showing you the one of my paper where I show the effect of parameter Q. Just here I'm showing you the paper in which up to maximum values the optimal parameter, the optimal alternatives is the same per by varying the value of parameter Q. Just I'm here to show you this another paper. Just this one. Yeah, this one. You see my screen now?
Yes, I can see your screen.
Here I show the variation of parameter Q. In this one, you can see that up to by using the value of Q up to up to this one, you can see that till 15, 16, 17, the outcome, the optimal parameter, the optimal alternative is A1. After 18, 19, 20, 30, up to 100 I calculated. The optimal alternative is changing by by changing the value of parameter Q. Just I show the graph as well here. This is the graphical representation of the parameter Q.
Okay.
Yes.
All right. Are you searching for something? I have another question for you.
Okay.
Okay,
Welcome.
so
You are welcome.
yes, so Mr. Nguyen stated that you listed computational time as your main limitation. So he's asking, can you
Yes.
share, for example, approximately how long it took to compute the ranking for the medical oxygen supplier case study?
Here, yeah, here I calculated the time, but didn't show in my any research paper, and it take up to 30 second, 40 second, which is also a minimum time. Higher time, but I'm working to decrease the same time as well. This is also no high. This is also maximum time, but I'm still working to reduce the computational cost in calculation as efficiency as well, to reduce the efficiency of the codes.
Okay, Mr. Nguyen Hute, are you okay? Do you have any more question?
Hey, Mike.
Yes.
Hello.
I can hear you.
Can you hear me?
Yeah, I can hear you, sir.
I'm sorry that I'm late, but I actually heard your presentation, and I think that is a very nice presentation about the design, the new operator, and decision making algorithms based on the Q rank. But one of the things we have to note is that we have to consider about the applications aspect. For example, here, when we design a new decision-making algorithms, it has to be strictly adhere to the data sets or case study. So besides the case study of health, is there any other case study that your algorithms, the decision-making methodology can be applied to? Yeah, this is my question.
Doctor, do you get the question? Can I repeat the question?
Please repeat.
He's saying that beside the case study of medical facilities, is your model applicable to any other case study?
Yes, of course. I implemented for several case study by developed novel ideas just in my present paper. You can see it here. I consider the AI. You can see that. Yeah, is this one AI in imaging technology for diagnosis in healthcare with intelligent decision support system. Just I introduced the other novel idea, and consider another case study as well for the next for this paper. And now I'm working in healthcare site, and the AI is the most popular area in the world nowadays. Now I'm just working on the health side to how the AI are considered in the how we can discuss about the application of AI in healthcare side. Currently, I'm working in healthcare site, and different how to choose different variable digital devices, and how the physician can use AI to diagnose the patient, and how all these can be improved further as well.
Okay, Prof, did you hear him?
Yeah, so but I would like to know more information about the medical experience. For example, here in decision making, there's one important process that we can collect the decision based on the some type knowledge from expert. So, for example, here, if we transfer from case study from health to other case study in environmental or educations. So how can we collect and capture the knowledge from the expert in those cases? Okay.
Doctor, what he's saying that with reference to the existing model, which is in healthcare, now, for instance, we want to transfer this to case study to education or to environmental. How do
Yes,
we
yes.
capture this? How do we have this knowledge captured?
Please ask again. Please
Yes.
ask again.
Okay, so we have an existing case study which is on medical, right? So now we want to transfer this case study to another case study, for example, in environmental, or we want to transfer to education. Now, the question Prof is asking is, how do we capture this knowledge? How do we capture this knowledge?
Okay, I'm just showing another paper. Here I just for your information, I'm just showing another paper, a new type of science similarity based on intuitionistic hesitant fuzzy rough set for the evaluation of volatile currency evidence from Pakistan economy. I'm I'm showing you that how the criteria and parameter will be taken. Just I'm going to the case study. Just going to the case study section. Here is the case study section. I consider the current account deficit. This one is the one criteria, and I'm just showing the Russia-Ukraine conflict, and this one is the another criteria, and this one is the political turmoil in Afghanistan, and this three I consider, and I'm just showing another value, another one is well. Just I'm currently working on this one. I'm showing you this the how I consider the criterias and some alternative as well. AI and emergency technology for diagnosis and healthcare with intelligent decision support system based on Keurang Orthopair hesitant fuzzy rub dumb aggregation operator. So here I'm just showing you the criteria as well, and I'm going to the case study section. That how we can choose the how we can collect the information from expert, and how we can choose the criteria regarding your case study. In this one, this one I am showing you about the case study section. This one, yes. Case study application of the proposed model in AI-assisted medical diagnosis. Here I consider the criteria. Here consider the criteria: symptom severity, medical history, diagnostic test results, and patient characteristic. I consider here four criteria and four alternative. Then the expert will provide the information in this one. I'm in this paper. I visited several hospitals and collected the information from expert of the same specialization.
Okay. There is a question raised by Nguyen Tuhe again, Nguyen Hute, sorry. So he said, you mentioned a future plan to apply the approach to AI-assisted diagnosis, right? So that could you outline how
Yes.
this model will work in the context, and what will the alternatives and criteria be?
Please ask again.
Okay, so he dropped a question in the chat. He said, you mentioned a future plan to apply this approach to AI-assisted diagnosis, right? So could you outline how this model will work in that context and what will the alternatives and criteria be?
I'm working on this now. I visited several hospitals and discussed with the specialized person. And some of them recommended me to consider these criteria. But now I'm working to visit the high level hospital in Pakistan and collect the information, and we can extend the criteria as well. And all in my and I slide I presented, I consider 4 criteria and 4 alternative. We can extend these criteria as well, alternative as well, by expanded the same idea. Now I'm just in visiting to different hospital to collect the information from the expert to how to use the AI and which one is the hottest area in medical healthcare, and will collect the information from expert. Now I'm working on these things.
Okay. Nguyen, do you have more question? Is that okay for you? Anyone has a question or anything to share regarding this topic? Okay, one more question. So, incorporating the generalized fraction, Orthopair. So your presentation title mentioned generalized fraction Orthopair fuzzy rough information. But seems the body focuses on the
Yes.
integer wrong Orthopair set, right? Which is Q equal to 3 and the general integers,
Yes.
which is Q. So can you elaborate on the unique
Yes.
mathematical formula and maybe the practical advantage of allowing Q to be a non-integer fractional value, and how this feature enhances decision support over the existing integer wrong framework?
Yes, sir.
Okay.
Yes.
So how this
Currently,
feature enhance the decision
the
support?
fractional fuzzy set was introduced by a mathematician in, I think, in Canada.
Okay.
This is the very recent topics in fuzzy set. Uh, I'm working on this area, that how you can. It is not an easy way to how to implement in the area that I developed. Now I'm currently working on it, and we will discuss about the application of advantages and disadvantages of the fractional fuzzy sets.
Okay.
I will change the value of different parameter as well, and just I show you the paper by increasing the value of Q, decreasing the value of Q, and will show the effect of several variable. And I also discuss the geometric properties, several property of the aggregation operators, and then applying the fractional the idea of fractional fuzzy set and the rough set. I am just working on it, and I sum up my theorem I proved, but still working on it, and how to show that to show how the fractional fuzzy set will affect the decision making.
Okay. Thank you so much for your presentation, Dr. Abdallah. I don't know if I called the name very well. Is Atwalla, right?
Ataullah, I am Dr. Ataullah.
Okay.
I just want to one thing that can you all the audience introduce yourself
Yes. So because the
and
audience
show
were become a little late.
your picture as well.
Yes. So the audience, we started earlier and a few of them were already there then before others joined, right? So I would like to
Yes.
introduce the members of the audience. Okay. So
And can I ask that how can you show your picture as well, all the audience?
yes, so they can show their pictures and possibly.
Yeah, thank you.
Yes. So let me start with
I just want to know about your colleagues, your students, and all the other professors as well.
yes. So what I will do is they will introduce themselves and field of specialty, or that's the area of research that they are working on. Okay. And then you will get to understand a little background. Okay. So
Yes.
can I start with I think some of the names are not the
Sir, Professor, just start yourself about your area, about your.
Okay, so my name is Michael Omar, as you can see from my screen. Okay, I'm also a PhD candidate, and I'm working on deep learning and machine learning field. So I focus on right now. My project is related to using artificial intelligence for prediction of groundwater quality in Vietnam.
Okay.
Yes.
Good.
So my area of specialty is machine learning and deep learning. Okay. So let me ask Mr. Tuan, are you around? Chanman Tuan?
Okay, Mai. So let me explain in Vietnamese to all the member here, right?
All right, sir.
Xin mời tất cả mọi người là bật cam lên là để ta chụp một cái ảnh chung nhé, chụp một cái ảnh chung cho cái buổi seminar hôm nay.
Just so feel free, please, to introduce yourself, all members around, okay?
I think that let me briefly introduce the team member here because we have a limited time, and thank you again for your presentation of the Dr. Anta. So I'm sorry I'm late because I have another meeting this morning, and I cannot join and to hear fully presentation. But I also request to all team member of our lab here, and as you know that this is some parts of the member of our lab in VNU in Hanoi. So they join and they have same feeling and knowledge about decision making and application in AI. So most of the people here are come from AI RC Center and Lab AI 4.0, and we are focusing on deep learning, machine learning, and Gen AI, and so on. And I hope that one day you can come to Vietnam and we can
Thank
do a
you.
lot
Thank
of
you.
research and yeah, and especially to enjoy the nature and feeling in Vietnam, and especially you know that the Vietnamese people are very friendly, and we have a lot of good food, and also the sightseeing is beautiful. So once again, thank you for your presentation, and yeah. So before we close here, Mike,
Thank you
can you
again.
please
Thank you, Pariu. Thank you, Pariu, sir.
yeah. So before we close here, so Mike, can you please take a picture of our own audience in the seminar this morning? So Mike,
Because of all the audience.
yeah, for our audience,
Please
take
share
a
with me as well.
yeah. Mike, is it okay?
Yes, let me push to Tam. Tam, can you help me take the picture?
Okay, I could help you.
Okay, go ahead.
You can say 1, 2, 3, right?
Okay,
Yes,
and
Tam will do that.
1, 2, 3. Maybe try again. People stay here. See me. Okay.
Yeah.
1, 2, 3. Okay, thank you.
Okay,
All right.
thank you all the college and team member and our lab mate here. And our seminar today is very special because we just invited one speaker from Pakistan to share his research about this making metrology. And we hope that we can have a more presenter, and especially that we can. Do joint research project together. So, Dr. Ata, thank you again.
Yeah.
Okay, thank you so much. This brings us to the end of the presentation for today and the seminar for today. Have a beautiful day, everyone. Thank you, and see you some other time.
See you soon. See you again.
Yes, see you again.
Thank you to everyone. Thank you to you. Thank you.
All right.
All right. Thank you.
Bye. Yes. Tamoy, you can check on the cloud, the video, okay?
Okay. You can
All
stop
right.
and send me.
Yes. I
And
need to end, okay?
okay, okay.